Welcome to 5th Iranian Geometry Olympiad's solution guide. Here we will discuss about problem 5 of advanced exam. If in quadrilateral ABCD, lines AB and DC are parallel, then this arc FC is equal to this arc FD. And so because this angle is half the arc FC and this angle is half the arc FD, these two angles are equal. And because AB is parallel to DC, this angle is equal to this angle, and also this angle is equal to this angle. Similarly, we can prove that these two angles are equal to. So these four triangles are similar. And because ABCD is cyclic, this angle is equal to this angle. So these two angles are equal. So triangles BEC and AED are congruent. So EC is equal to ED. Similarly, we can show that FB is equal to FA. So triangles FBH and FGA are congruent, and also triangles HEC and GED are congruent. So distance of L and K from line DC are equal because the radius of incircle of these two triangles are equal, and so LK is parallel to DC. Similarly, IJ is parallel to AB, and so LK is parallel to IJ. Now, because these two triangles are congruent, IG equals to JH. Similarly, JL equals to HK. So IJKL is an isosceles trapezoid, so it's cyclic. And if AB is parallel to DC, we prove this problem. Now, if AB and CD are not parallel, they meet at a point that we name it by M. Now, this angle is half of the angle AE in this circle. And because EM is tangent to this circle, AEM is also half of the arc AE. So these two angles are equal. Now, MD times MC is power of point M with respect to black circle and orange circle. And also MA times MB is power of M with respect to black circle and yellow circle. So power of M with respect to black circle and orange circle and yellow circle is equal. So ME squared, which is power of M with respect to yellow circle, is equal to MF squared, which is power of M with respect to orange circle. So triangle MEF is an isosceles triangle. This angle is the green angle minus the blue angle. And so this angle is green angle minus blue angle. So these two angles are equal. Similarly, we can show that these two angles are equal to. We know that angle FJH is 90 degrees plus half of this angle. And the angle FEK is half of the angle AEC, because EK is angle bisector of HEC and EF is angle bisector of HEA. So we know that FEK plus half of this blue angle is 90 degrees. So because FJH is 90 degrees plus half of this blue angle, so FJK plus FEK is 180 degrees. So quadrilateral FJKE is cyclic. And similarly, we can show that FILE is cyclic too. Now, if I draw angle FHE's bisector and name the intersection point with EFQ, because I know that triangles FHE and FGE are congruent, then GQ is the angle bisector of FGE. Now, if JK is parallel to FE, because we know that HJ is exterior angle bisector of FHE, then HQF is 90 degrees, and so the triangle FHE is isosceles, and so FGE is isosceles too, and so GQ is perpendicular to EF. And because IGQ is 90 degrees, because GI is exterior angle bisector of FGE, then IL is parallel to FE2. So JK is parallel to IL. And because FJKE is cyclic, JK and FE have the same perpendicular bisector. And also IL and FE have the same perpendicular bisector. So IL and JK have the same perpendicular bisector, and this shows that IJKL is an isosceles trapezoid, and so is cyclic. Now, if JK is not parallel to EF, then these two lines meet at point P, which is harmonic conjugate of Q with respect to F and E, because we know that HP is exterior angle bisector for FHE, and HQ is angle bisector of FHE. And similarly, IL and FE must meet at P, because they must meet at harmonic conjugate of Q with respect to F and E. So these three lines pass through point P, which is harmonic conjugate of Q with respect to F and E, like this picture. Now we know that FJKE is cyclic, so PJ times PK equals to PF times PE, and also FILE is cyclic, so PF times PE is equal to PI times PL, and this implies that PJ times PK is equal to PI times PL. So IJKL is a cyclic quadrilateral. And this is the end of proof of problem 5 of advanced exam. Thank you.